Euclid's Elements for High School Classrooms Revisited. Will be presented by Faith Hoppen, who is a math teacher at Lifegate Christian School in Omaha, Nebraska. Please welcome Ms. Hoppen.
All right, so I was at a school that was using just like normal geometry curriculum, and then we decided to turn classical, and I felt that finding classical math material was incredibly difficult because it's either too difficult for your students or it's like all these different excerpts are taken and put together to form an idea that we would normally teach in one class period, but now we have to look everywhere to teach them to our students. And so I struggled until I found Euclid. Euclid's Elements, phenomenal book and written at the level that our students can handle. So that's what we're going to discover today. We're just going to look into it. And I think even if you're not a math teacher, this will be fun. So my goal is I'm going to talk for a few minutes, and then I've got activities for you guys to do so you can kind of experience what the students would do in my classroom when they're running through this material. So problem is our kids just take notes, and then they do their homework, and then they study from that, and they get an A on their test, and they do it all again, and again, and again. And we're missing the beauty that lies in math. Okay? If you love math, you know there's beauty behind it. We as Christians all see the beauty that God puts behind all of this. And so as much as my type A personality loves this model, I want to take notes. I want to know exactly what I'm going to get on the test. I want to be able to process it all like that. That's not an efficient way to teach our kids, and it's not a way to get them to be thinkers and learners and arguers, because that's what we want in math. I want you to challenge it. I want you to be frustrated with each other. I want you to question each other, because that makes you stronger as a questioner, but it also makes the other person stronger as a defender, and then we know our material better. So that's the issue, is we're just stuck in the system, but we're getting out of it. So we've got this quote that has been just haunting my brain for years. We have to give them something even better to love than the grade. If the grade is the highest, most pleasurable thing that comes out of this learning, we've lost. How many of our kids want a 4.0? That's their goal. 4.5, whatever they're getting, okay? They want that because that grade defines who they are, okay? Because that's what we've made education in America, is that the grade defines who you are. The grade gives you success. And I think as classical educators, we're trying to unravel that. Not that we're not giving our kids grades, but we're trying to unravel it and say, your actual learning is so much more important than this specific letter. And so let's not focus on the letter, but let's focus on the discussions we're having in class, the relationships we're making, the learning we're doing in that. So a little bit of history here. You can do some of this research on your own. I don't need to teach you all the history stuff, but Euclid's Elements was written in 300 BC and was used as the main math textbook until about 1850, 1860, when people decided it was not progressive enough. And then we've got Sylvester there in 1861, who is known for saying the early study of Euclid made me a hater of geometry. Well, that is a bummer when you're one of the big guys in math and you make that statement. So then later that year, Frederick Temple wrote a text to supersede Euclid. Just another geometry, plain geometry, but without Euclid in it. We've got non-Euclidean geometries, algebraic geometries. Then 1870, an anti-Euclid association. They're not hiding what they wanted. Later changed their name to the Association for Improvement of Geometrical Teaching. Published the Elements of Plain Geometry, which is a book based on Euclid's Elements, but it's not Euclid's Elements. So just another math textbook based on that, but with a different name and different authors there. But then 1888, we got Oxford and Cambridge, who were the big guys in the market, and they said, you don't need it for geometry. You don't need Euclid's Elements anymore. And so we've got more people wanting to make it practical. And 1903, we just say, teach geometry as you're teaching geometry, but it doesn't have to be from the elements. And I think as we discover today, you'll realize how sad that is, because they are just truly so beautiful and so clearly laid out. I think, I don't know, raise your hand if you're a geometry teacher. I should just put us all in that box. Okay, so as a geometry teacher, there are so many things you're asking these kids to memorize, and sometimes they even get mixed up in your head. You're like, this property, this theorem, blah, blah, blah. Because you need the further understanding of what's actually happening instead of just memorizing the specific acronyms or theorem names that the book gives you to memorize. And so I think that's what we're diving back in here with Euclid is understanding what's happening behind the name of what's happening, because he didn't give them cool names. He called them all propositions, so they all have the same name. So he took that away. So if Euclid's Elements is 13 books, originally written in Greek, now they're obviously in English, but he starts off with just asking people to agree with him on 10 things. He says, if you can agree with me on these 10 basic ideas, I will prove all of geometry. Okay, so the first 5 are common notions. I call these like the non-math ones. They're things that anybody would agree on, okay? So first one, things which are equal to the same thing are also equal to one another. Seems fair, but at the time it had to be stated. Number 2, if equals be added to equals, the whole are equal. Okay, addition property there. 3, if equals be subtracted from equals, the remainders are equal. 4, things which coincide with one another equal one another. So obviously if 2 things are the exact same, they're equal. And 5, the whole is greater than the part. If any of you disagree with any of those 5? All right, I think we're good so far. We're halfway there. So basic things there. And then his next 5 are called the postulates. And these are slightly more mathy, but barely. So number 1, to draw a straight line from any point to any point. He said if you can agree that we can draw a straight line between any 2 points, we're good. I need us all to agree on that. Okay? Number 2, to produce a finite straight line continuously in a straight line. Seems fair. These seem like things that we don't even question normally. We don't question them because Euclid proved them for 2,000 years. Number 3, to describe a circle with any center and any distance. Okay, we can make circles. At the time, all Euclid had was a compass and a straight edge. Okay, so no angle measures, no agreed upon measurement system, so rulers weren't an option at the time, which actually, it's beautiful. In this entire book, he never once really uses a number. There are no numbers in here. He'll say like, it's twice as much as something, or it's half of something, but never a number. That's incredible. He like did all of geometry without any numbers. Even like no angle measures in here, because they didn't have protractors agreed upon then. And so he's proving all of this based on these elementary tools that basically anybody would have known or would have agreed upon. So he's not using any fancy math to prove this. So number 4, all right angles are equal to one another. So he does go on the assumption that you know that a right angle is 90 degrees. Maybe he defines it in his definitions at the beginning here. Well, kind of. There are no numbers. He says when things are perpendicular, then they make a right angle. So if you know what perpendicular means.
No, he says the lines that are on a line so that the adjacent angles are equal. That's how he defines right angle.
When a straight line set upon a straight line makes the adjacent angles equal to each other, each one is called right. The straight line standing upon them is perpendicular on which it stands.
Yeah.
Yeah. So that's Euclid's way of explaining it without giving you any numbers. And then number 5, the most controversial of them all, that if a straight line falling on 2 straight lines makes the interior angles on the same side less than 2 right angles, the 2 straight lines, if produced indefinitely, meet on the side on which the angles are less than 2 right angles. So we would agree if this is less than 2 right angles, these lines are going to intersect at some point. But if you want to start an argument in the math world, take postulate 5, because a lot of people like to argue with you as to whether that's just an acceptable thing to say without being proven. So based on this, I started teaching just straight out of the text. I had no idea what I was doing. I gave the kids all a text and we opened it and we just started working through propositions when I first started doing this. And it turned out I figured the best method was you have the kids work through a few propositions the day before, and then the next day they get up and present. And then I've written like discussion questions in the stuff, and so then they have to lead the discussion based on the propositions that they're presenting on. So you as a teacher are truly just a facilitator. I mean, every once in a while you can get into discussion, but you are not meant to be a part of the class really at all. You are just watching them learn this. And if there's something they truly can't handle, then talk about it with them. But most of it so quickly follows from the previous thing that it is pretty straightforward in that way. And so it is incredible to watch your kids just like get up and start talking about geometry. Oh, that's really cool. Like they're literally teaching this in that way. So just to look at what the propositions look like. So this is the first one that's in the book. On a given finite straight line to construct the equilateral triangle. Okay? But you can't measure anything. So you can't measure angles, can't measure your sides. You just have compass and a straight edge. And so you'll notice like he's got in the brackets, the postulate 3, postulate 1, definitions over here, and this is common notion 1. And so everything that he does, he gives a reasoning for why he was allowed to do that. Okay? And so there's not a point where Euclid just decides, well, I wanted to do this because it seemed like it would make sense. He's like, no, I'm going to defend everything I say because he knew that that was necessary. And so that's also the beauty in this. Like I said, there are 465 propositions in here, but he's laid them out so that he can't prove one unless it relies on the things before it. So nothing can be proven unless other things are proven that are necessary for that one. So I put proposition 17 up here too. We're still in book 1. In any triangle, 2 angles taken together in any manner are less than 2 right angles. I think we would say, duh. If 2 of your angles are 180 degrees, you don't have a triangle. But what I want you to notice is like here he uses 1.16. So that's saying that fact that he just worked through relied on book 1, proposition 16. And like this one relies on book 1, proposition 13. And so they're all things that he's done before and then is bringing back those ideas when he's proving this. So, yes?
So you don't really have to teach proofs because that's how they're learning.
Yeah. The whole class is proofs. But, yeah, don't present it that way.
No.
Yeah. Present it in the best manner you can, and then they'll run with it. Okay, so in like the material I had made, this is what I would have done with my students. I've got like the copies over there if you want to look at them, but it would have been blank here, and then they would have drawn these 2 figures on this proposition. So they would have used their Euclid's elements. Every student gets one of these, and they would go for book 1, proposition 17, and would have led them through to draw these 2 different pictures. And then we've got discussion questions. So the person who got up and presented is also going to lead the discussion on these questions. And like this first one, I mean, there's no right or wrong. Did you expect to see a triangle? I don't know. What do they think? Like, did they expect to see a triangle or not? And then this one's talking about the 5th postulate. Do you think it should be freely accepted or not? I think that one starts a very unique conversation because some kids are just like, yes, accept it, I do not care. Like, it's fine, it doesn't matter. And some kids want to argue for the proving side of it. And so it creates an interesting Socratic discussion with that. And then this one, it's in the printout, so you guys can kind of read this on your own. We don't need to probably dissect it together. But just an interesting thought there with that. I'll let you read that in your free time, because I want us to get to having some fun today. So these are my students presenting, just up at the board, giving their presentations, and they've got like the class sitting around listening, and then they'll start the discussion after that. So what I have included, obviously there are 465. I only cover 120 propositions over the course of the school year. I use the first week or 2 to focus on logic and debate and things like that because my school doesn't teach a logic class, and so I think that's necessary. And then it's all laid out so they get certain days to work and certain days to be up presenting and stuff like that. Culminating at the very end of the year, there is a end of the year like project that they do over all of it. But these are the books that I found. They're all important. I shouldn't say they're all important. But like book 5 is all about magnitudes. Interesting, but maybe not to my 15-year-olds who have rulers and things that they can use. modern stuff. And so while breakout is interesting and like historically important, it's not something that like I would focus on throughout the year. But then, if you get to like book 13, if you've got extra time, it's got like fun drawings. Like you've got students that want like advanced stuff and they want to create like the cool drawings that Euclid did in the back. Like that's your opportunity to give them that. And so I don't include book 13 because it doesn't seem like something every student should be doing. But if you have students who are super motivated, I would encourage you to include that as well. So, all right, so just putting this out there before we start our activity. If any of you are interested in reviewing some material this year, I've been writing this year-long on Euclid, and first semester I have finished, but the second semester is recently finished and not edited. So if you are interested in being an editor, reviewer, any of that, I would love to hear from you. I currently teach middle school math, so I don't have the opportunity to work through a lot of it with my students every day. So that's kind of my thought on that. Okay, yes?
This is a question that I get for most things like this.
Yeah.
Something along the lines of, so you're only doing part of the book, and are they going to be behind? Are they going to be missing something? You know, my kid's going to go to college. Is he going to have the math he needs? Yeah. Okay. How do you answer that?
Trust me, I love that. I've got a lot of math education, don't be concerned. Yeah, I would probably say geometry is, not a lot of classes build on geometry. It's fun, it's interesting, I think it's necessary, but I mean algebra 2 maybe a tiny bit, calculus maybe a tiny bit, but it's not things that these kids can't learn in those classes. So that's my thought there. Yeah.
Well, and you could probably answer the question with, we're teaching them how to think about the math in this class and not necessarily, they're not missing anything because we're just learning how to think about ideas and how to approach those ideas. So you can't, because you're skipping books doesn't mean you're missing anything. It's just, you're not covering that little bit of the math.
I mean, if it's a parent, I'd say feel free to do it in the summer. You feel free to, I don't care. Like, I only have 180 days to work with your kid. Yeah.
I mean, a different concern other than not having the whole geometry. It's not my concern, but it's more like, you know, like, are they going to forget their algebra this year?
Oh, yeah, that's fair.
And I mean, I guess, are you not going to practice like formulas for area of volume, stuff like that? Like,
Yeah.
Why?
Were you raising your hand to answer for me?
No, well, I'm
a friend back there.
Yeah.
it relates to that, but you answer first.
But you want me to answer him first?
Yeah,
Oh,
it
okay.
relates to his question.
That's fair, 100%. I would say there are certain things like later formulas in geometry that I think are important, but the basic formulas, they learn in 7th grade, they learn in 8th grade, they learn in 6th grade. I mean, we've crammed them into their heads for years, and so if they don't know them by the time they get to their freshman or sophomore, junior year of high school, I don't know, like, you're gonna have to Google it later. I don't think teaching them again is going to make them remember it, but you're welcome to chant them. I don't know. Yeah, but Euclid wouldn't use them specifically. Yeah. Okay.
So I know that our school, our math teacher, our upper level math teacher, like, it seemed like he does Euclid once a week with all the upper level math students. I don't know if you've met Nathaniel Hahn.
Yes, I have.
Okay, I was gonna say. So I'm here as a parent because I don't know much about Euclid.
Oh, fun.
I taught lower level math,
Yeah.
but never geometry, and I never, except for what with him. But it does seem like it has functioned well while they continue in their regular upper level advanced mathematics. And then they have these really interesting Euclid discussions once a week
Oh.
that I want to sit in on.
Yeah. Does he still teach geometry?
You'd have to ask that for him, because my eldest is not in geometry yet, so I haven't paid as much attention.
Yeah.
But that is an alternative model.
Mm-hmm.
I don't know the pros and cons. I guess
Yeah.
that's what we're experiencing right now.
I feel like, especially if you didn't have the authority to completely overhaul your geometry curriculum, that would be a great way to go about it, is to do like that supplemental. Yeah.
I can just offer one way in which it integrates across all the things that we're trying to teach as class of educators. When we think just about that first common notion, the things that are equal, they, you know, to another, if A equals B and B equals C, then A equals C, right? They'll learn that later. They'll also learn that and apply that when they start cross multiplying in algebra. And then you can even, if you want to take geometry to the sort of higher questions about theology, you can apply it to something like, well, in logic is a hypothetical syllogism, right? If you take it into theology, then it's you can apply it to something like, we hear if grace then faith, if faith then works. That's a hypothetical syllogism scripturally. So if grace then faith, if faith then works becomes if faith then works. Right, so the mathematical principle of the common notion explodes across curriculum issues. I mean, just offering that as they can memorize the formulas anytime.
Yeah.
So when they're drawing things,
Yeah.
I used your first 6 book
Yeah.
from in the second semester.
Okay.
For like the construction ones, you make them follow the steps every time. Like, because some of them, he references something he did previously. Do you let them just kind of skip ahead to that step or not? Because some of it would take like 45 minutes. What do you do for that?
Not in like the first few weeks.
Yeah, no.
But then later on, if it's like something that they've done 5 or 6 times as a class or anything, like, okay, well, we've already proven that this is what we can do. And so, which then maybe that would give you more time in the semester to do more stuff. So.
A follow-up question.
Yeah.
How do you grade things? Because I was doing like a participation scale and I was trying to figure out how exactly I wanted to do it.
I don't grade well. I will admit, I struggle on grading this. Because the participation is really what you want to grade them on, because I don't want to tell somebody like, oh, you didn't discuss well, like B-, that's hard because a lot of the students surely are participating. But I did have a teacher, I don't think she's at this conference, but she emailed me with some rubrics a few weeks ago and said, hey, I've been using these with your material this year, do you want them? So I haven't looked at them yet, but I can forward them on to you, because that's what she's been using. Did you have something?
Yeah.
Yeah.
I'm just guessing and I'm trying to absorb everything here, but if you've got this long proof, I know someone like myself, I personally feel really kind of overwhelmed, and I think just the action and having students really learn the action of parsing through that is super formative, because what it does is it gives them the confidence that any problem that they look at, they go, oh, I know what to do. And to me, that's very formative. And so it's kind of that learning how to learn sort of thing. And so I feel like, I love this idea. I want to be one of those 5 people that get to review what you have. Because my daughter's going to be doing geometry this year. And up to this point, I've used textbooks, but I find this refreshing. So it'd be really fun to just talk about how do you develop those questions and things. Because again, you want your students at this point to be rhetorical too. And they're resisting, right? Like they've learned the Pythagorean theorem, or they've learned about, certain, constructions, whatever, in a basic way at the middle school level. So this takes them to the next level. And so then they can, they're going to see it over and over. I do think the catechism idea would be really great to go with it.
I took notes in your session.
And just the idea of, you can still practice these things in a beautiful way, but I think this is really lovely what you started here.
Yeah, and I think, sorry, one more thing, and then I think there's some beauty in the way Euclid lays it out, because it's obviously not the modern English that we would normally speak, and so sometimes they'll get like 3/4 the way through, and they'll realize what it's proving, and then they get really excited. I know this one. You do, yes, but now you've proven it. So that's kind of exciting when they don't realize what they're doing until they get to the end, and then they've done it. So yeah.
I just wanted to say also, if you dwell with Euclidean proofs for a while, the trivium is all there at once. Right? You're practicing the grammar. When things are proven, you learn, that opposite angles are equal. You learn all these things because you're applying it. The dialectic is there because you're building the argument. You're using what you had before and applying it to what comes afterwards. And if you stand up and present it the way that you have your students doing it, you're practicing rhetoric. So a single Euclidean proof lets you get all of that.
Yeah.
Yeah. And it's much richer, because that was part of what I was saying too, is to find the amazing problems or circumstances that really light your students up. That's what you want, and this is a great way to do it, I think.
Yeah. And I think like the first few propositions, maybe you have to present a few, because it can be like terrifying to get up and like do math in front of your peers and have them question you. But once they really get into it, I mean, truly as a teacher, you almost step back and just play devil's advocate and just kind of listen and challenge them and see what they can do with it, because they do become so strong in that. So, you ready to do some work? All right, I would encourage you to be in groups of 2 or 3. You can't do it individually, but I'd encourage you to be in groups of 2 or 3, and then I'll pass some papers down your row. I'm going to give you, so this is what each student would get in their workbook. So it's got like the blank proposition page, and then I'll give you the proposition, you're going to work through it. And then on the back, it's got like the extra questions that they would work through. This one would be probably January or February of your school year. So they've done a lot of things before they've gotten to this. And then each row is going to get a bag with their, like the stuff the students would get. It's got like pencils, compass, straight edge, stuff like that. If you need extra, there's more up here. Okay, you're going to have to share the propositions, but, oh, sure.
My favorite proposition.
I'm not getting to that.
I probably might have slides.
I only taught it in this number.
Teach everybody, how can I help you best?
One of my strong sides.
I didn't stop to teach it, and certainly right now.
So then I skipped
Launch it, but I mean, I skipped through it.
And I know. Like, oh, I better go back to this section and get a refresher.
This is my video, which is a lovely way to actually teach a lot of great things. But it was a nice overview.
Not really a challenge. But I'm right. I know her second period. So if I don't know everything. What like different walks of life, right? Yeah.
Okay, so everyone has a blank page in front of them. The proposition.
Yeah, so
Like your goal is to try and follow this proposition using only a compass and a straight edge. Okay? If there are protractors, don't use them. There are rulers, don't use them as what they are. Okay? Only use the compass and straight edge. And then when you finish working through that with your team, you can look at the back.
I don't have that. Yeah, this is what I would do. Yeah, well, is that extra dimension?
You only like take out.
Oh, I see. Yeah. I would have loved. You guys have. Okay. Would you have one? But maybe it's just
but anyway, what I was saying is, we might. Oh, like.
yeah, no, this is
I love
yeah. Yeah, she's so literally. Oh, so I guess it would be. So here's the actual proposition. There is a ladder.
Yeah, we have straight edges. So are we supposed to be constructing the behavior?
Oh, yeah, I see that. So I think we're following the
Following the steps? I don't know what.
correct. And then there's question B.
We only need to do it in one of us, really.
Straight line.
Let A be Draw
This is the good thing. There's a lot of analysis. Actually, we can figure this out. And this is the actually do.
You see the straight, it's because like the,
So this is, I'm trying to understand. This is like in she's got these blank pages.
and then like this.
They have.
It's not good that I'm.
And it's, and this is what the page is. So they're trying to draw this figure.
That's the goal.
Well, it's also interesting that it has the.
And this is what's
it has all the steps laid out, so it's
So that should coincide somewhere with what's on the chart. But you have to go through all the steps.
But I think they're here.
Yep.
You tried.
So find you all straight this over.
I don't really know how long.
Oh, I see. So
Never do that.
I find it helpful, especially at the beginning.
Finding a
To really navigate it.
But see, I think this line is that yeah. So I'm really lucky. So I'm really coming, no, I mean, literally, I was coming out for so I can do that in this is really important. It's really fun because every little bit means something. Like, should I make my line be a higher length of this?
whatever it is.
We can do it wrong, but
Also, the fact that do we someone come?
right.
Those would parallel, there's a way to do it.
Yeah. This is but it was similar in the way that it had really all those instructions. Yes, exactly. Yeah, you're right.
And then you answer.
And then the question comes back and asks
So that's
which.
I mean, that sounds
It's interesting to me that say that how
Right.
like I think
so see, so then it's like
yeah, and it's just trying to like you get completely different picture.
yeah, so that's the
Let them be.
I don't know myself it doesn't say just that.
I mean, this line.
Yeah, you're gonna have to.
Unless there was a step like given that like
There's
oh yes, great. I apologize. So we're looking at, can we have a picture or not? And then do we have to have more information? Okay, right. We have to have it. Yeah, but interesting when you would draw the
because this is already like.
yeah, I know. Like, drawing in the sand, you know, like how would you do?
Is there a compass?
Yeah,
Because I followed and I totally know that's what I
They
do.
have to, okay, join this to make sure that it's.
Yes. That would have been a previous proposition we would have worked. Yeah, so yeah, that's things like, what did you guys do this semester? Semester one last year, but like, it's using book 131, book 62, like, those are things. Last year, you probably haven't.
So they would, yeah, this is not gonna show numerally. Here's my number.
Yeah, which is what he was asking earlier, so sometimes the same thing, mine's 4 times, things wrong. At a point, you don't need them to do it the exact precisely every single time, but once they get that idea down. Yep. Which, yeah, the picture does actually come in the book as well. And then on the back, these are like the proportions that are proven here, that lead to the conclusion, and so it makes sense with it. But I asked you to go through and like color code them all. So like it shows the different things that you would have needed, like this, the secondary, and the final things to give you the complete understanding.
And that is according to.
Then,
Put my age up. Basically. But again, you change that
Here.
or highlight.
But I like that.
Activity.
I feel like there's so much, like I like doing homework with it in class, like they come, but then there's the element of Lutheran thinking instead of letting other people do it.
Yeah.
I feel like this, you have to see that
Yes. Yes, exactly.
we'll look at Carol. So we learned how to make Carol. This is like 21, process 31, we learned how to make Carol lines in class. Yes. We just help
This one gets a color. Oh, so as far as I can tell, it's considering FD meeting has been already put to FD.
Yeah, I that's what I was assuming. And I'm like, I know, it's kind of, these are probably for
Huh?
Yeah, that's what I'm saying, that's the
I know.
part.
She showed. Well, I think it does require reading ahead because you need to.
Failing already.
I guess you can still join CB.
Well, you would have that as a theory.
Yeah, yeah, because finding a non-example or something that doesn't work, that doesn't work. That's okay. Directly. Right, of course, yes.
Say, right, anything else?
Maybe they're neither.
What if we like,
They're not for this.
Yeah, but that would be, or she had very, very.
because then you can't join.
Yeah.
But then that makes you just like, oh, yes, maybe it's just gonna be like, we're not considering the instructions in advance.
Yeah, right.
It's the first class I took.
Color would be great.
We have
So I haven't got.
Did she? There might be a few things.
Oh, okay, so basically this is using that common notion, if something's equal to something, it's equal to, like, If you say this is X,
Yeah, so you this here.
yeah, this is Z.
I don't think that's the last. Yeah. Okay. Reading through and just saying.
X is to Y.
Yes, yes.
X is to Y.
Yep, yep.
And
Yeah, so you just have
Z
to
is Y. Z is Y.
That'll be
So
interesting.
therefore, Z is X. You know.
Yes, that makes sense.
Color code reports. Okay, so you got your highlighter.
Oh, I'm not sure where H comes in. Like, why was that even? H and K aren't even talked about.
Yeah, because this is like.
It's like H and K are.
Doesn't mean replicate the drawing and
Or
then,
similarity in this case.
but like, if we do,
Which comes back to that.
But I'm guessing that was needed in order to show this angle, this angle, and this angle. Which is how you can say those proportions are the same.
So this really shows you of this to that. Should be the same.
Yeah, because I think. It's kind of foundational for that. Oh, nice. So you maybe agree with their.
yeah, because I'm guessing what it's a verifier.
Like the.
I was gonna say, like, I think there's some sort of
Totally different from QE.
QED, that's what I was.
Because that's what I mean.
End of our day.
Which means basically therefore it's proven.
There's no explanation, right? Isn't that right? What is there?
Was QE.
Same.
Section FD, just a different.
Maybe the F is have faith in this proof.
Well, like, a separate thing. So, like,
Yeah, right.
how would you go about that question?
Yeah, there you go. Back as well. Yeah, I'm always thinking all the shapes and
Versus what we're reading, as far as we're giving an explanation.
Yes, yes.
So why, are you saying why it's important in the learning of geometry, or why it's important?
Or if this particular thing more like
Facts.
but I don't know. I mean, I'll be curious.
Did you figure it out?
Yeah. And you're like really zero.
That's the issue was.
Like,
How does it relate to
I've done it.
like,
Proven it and
So yeah, I mean, the proposition was.
Yeah.
You're not proving it, you're actually doing it, carrying it out.
Okay.
Okay.
uncut straight lines.
Okay.
Did it. So why is this important?
Oh, I see what you're saying. Yeah, we can actually really digest
Thanks to the positive.
They don't trust me.
Okay, real quick, if you have not gotten to that, you only have like 10-15 minutes left. I want you to be working on the back. You've got 3 problems there. Ignore the on letter C. It doesn't belong there.
Oh, I agree.
Well, it's not. It was a typo, but thank you.
So to kind of really digest this question here, we kind of want to use this, that works for you. Yeah, maybe.
He doesn't talk about it
Part of your, like, Importance in relationship to what?
And I think you,
Okay.
give an explanation, and I think it helps them simple.
Yeah, it's like, okay, that. Yeah. Oh, yeah, because full circle, what are we really saying? We have to go back to trying to show how. Crazy. Yeah, yeah, what is it really saying? Yeah, the idea of that's what I'm jumping on. So, but to say it like. Part of a sentence, like I need to. And this is the result. This is.
So,
That you have, right, I guess that's why I have to understand. Getting. So I think really could use some things you actually have to.
Yeah, so
And it's essential,
like when you're, that's why the parallel is important.
to start a sentence too.
This question here, so
Words to explain her own thinking.
I mean,
parallel
have a great thing, like, you know, that's similar, right? You have to
because
and have
the
that.
previous proposition was proven that the similarity of this
Exactly. And it's actually probably I don't know.
this line, we could draw this line as an angle. This one plus this one plus this one. Here's that same.
But again, you have to have they got the ratio of the size, whatever, all the angles are the same. And then
That's when you're like, you need, oh, this is my explanation.
Yes, this is your explanation.
Like,
No right or wrong.
the thing is, we know there's a lot of wrong. When you're like 11 years old.
so what one?
I'm good. I understand.
Yeah, it's like,
I'm not sure.
Can't say it the same
Because I always think of fifth as best.
Right. The ratios are the same. Not that their lengths are the same, but how they're related to each other is the same. Yeah, it's like fractions. Reduced. They all come back to the same
this like force is
I think us jumping into six like this is the beginning of because they would have been exposed to the idea of similarity allows you to give this
I like that.
Right. Like on the back side?
Oh, no.
Oh, just the actual, yeah.
I know it's over. It's like an easy way to.
Right. But it might be,
there's no numbers in the book. It's mind boggling.
because that's my. Yeah.
That makes sense, like, geometry is the base. Well, it's the base. It's basic. Planning situations, active numbers are evident, like, it should apply to real numbers. And that's why you start with base. We all agree with all the things.
But you're right, that would be
That's what I Right. Or to show,
Well, and then she's going back to the text.
yeah, we have to have that.
Up until the mid-1800s to teach.
But then
Why?
I don't get
Well, because it's I don't want to be like,
it's arguments. But she asked that. Yes. Which is especially unlike other things, yes, unlike terrible. Or I say do
like that, like, shifted mindset, right?
I have it. Yeah. Good job. Good things here. Okay, so I'm the non-geometry. I colored what's happening. Oh, yeah, no, yeah, sorry, yeah, we're talking. Oh, that's kind of what you were thinking.
So, for the given exploration teacher, like what part of this was the... So just like, maybe not. Or can, like, how did this...
There's so much opportunity. Which, when he posed that question, why do you think it all seems and so yeah, they get to color, how fun is that? And we like my one here, she's like, yeah, you know, yeah, even better, then for me it jumped out as non-geometry, like, yes, what's going on?
I'm not sure why, I mean, I think is this now that we're using it for some kind of
Yeah. I'm curious in your class progression, like how long?
I like it.
Yeah, it's kind of be like
You have to draw it.
oh, right, you want to do all the different things.
Yes, like you have to draw it.
Yeah, that's a great part. There's a,
That's true. You were saying about having the words on all the walls.
yeah.
They say they're not and so when we class earlier, and like the walls were all whiteboards, which is
But I think
also should have been one to read something like math or I love it. Because the compasses are
find an adventure.
yes, like the yes.
I know. Anytime I'm like, this is up, just imagine that it is.
Yeah, right. Yeah.
Yeah.
That's it.
Other than just giving them like,
Right, I think that's actually really I mean, if you've ever done a list of stuff, that's super fun with the string. Right, you see, get a piece of string.
I like how it's like visualize like radius and area.
I mean,
What if someone in the shop put something right there permanently, put a clamp right there with your chalk.
okay.
Because we're permanent.
Yeah.
This is your string.
Yes, I feel like I can feel it right now.
Twice whenever.
and it doesn't have to,
Yeah.
And like put a string eraser on your slope so it doesn't slide around. And then some kind of clamp that you can build on the top.
well, you've got something here. Put something here. At least where you could have it here. Yeah.
Spring 2023.
Oh, it's really right. I got it on music.
Tell her. Just and I think we could probably like
How great. How great they actually are.
He says he has a whiteboard set.
In the explanation.
Oh, you have to know, like an I was just like, I think she said, and they're gonna. Yeah, thank
Try to sneak us into the teacher
Yeah, they all have
It's got basically, but we had a fact. It has one period and the questions. It starts I can even tell you, so I can teach it to them. They were like big clouds, like a list of things. You did it. That's yeah. The round like that. So Blake, is that similar?
I think we did it.
Like I can't.
I don't know.
For this last few minutes here. I hope you all enjoyed this. I hope you enjoyed diving into Euclid and just kind of seeing the beauty that he provides and truly just how simply he lays it out. Obviously, some of this stuff was based on stuff done in books 1, 5, and 6, which you haven't done. But your students would, other than that book 5, but they would have done this already. And so I encourage you to keep these, think about them, look at them a little bit more. If you want to see like what I would have laid out, like the student book or the teacher guide that's on the counter here. Maybe put all your stuff back in the baggies and put that on the counter. And feel free to reach out if you want to help throughout the year. It's been great to see you all.
Thank you.
I don't know. Well, yeah, that's right. Say, hey, maybe I'll get this version.
But I sound more like I understand. So I'm like, maybe you should go to something else. Because I understand. I can't feel like,
Now you can say you feel.
no, it's nice. Talk about it.